All right, now here's our job. We want to start putting these together, right? I want to give you an ionic formula, and I want you to be able to name it for me. So we're going to do some practice. Okay, ready to do this? Again, you've got your paper out. You've been taking notes. Let's do some practice together. All right, we're going to start off nice and simple here. NaCl. I know it's an ionic compound because it begins with a metal and it ends with a nonmetal. Okay, so metal, nonmetal is ionic. So I'm going to use the rules that I just learned. And I just learned that the first thing in the formula is the positive. That's my cation. Cations are named by just taking the name of that metal. And then you just have to decide, do you need a Roman numeral with it or not? And remember, we just talked about you only need Roman numerals if you're talking about those metals that are in the middle of the periodic table. Is Na one of those? Of course, you're going to have to be looking at a periodic table to do this. So if you don't have one available to look at, you're going to need to pull one up, right? Or if you have one printed out, you can look at that one too. So if you were to find Na on the periodic table, it's in the first group, right? It's in group 1. So Na is always positive 1. Do we need to tell somebody that it is always positive 1? Nope. So the name of the Na part here is just sodium, right? That's the sodium ion. Now the Cl part is the negative, right? That's my anion. The anions always come second in the formula. It's just one nonmetal, right? It's just Cl. So what did we learn about the negatives that have just one nonmetal to them? We have to change the ending to "-ide". So Cl on the periodic table, the Cl says it's chlorine. But since it's the anion, we have to call it chloride. All right, now I'm just going to put those two together. Since my formula is Na and Cl together, then I'm going to put these two names together. Sodium chloride. All right. Okay, let's try another one. Ki. So let's see, Ki. So the first thing is my cation. So that's my metal. So I have to decide simply, does my metal need a Roman numeral? Is it in the middle of the periodic table? Or is it in one of the groups where I already know what charge it is? K is in group 1, right? If you look it up on the periodic table, K is in group 1. So it's just positive 1 all of the time. I don't need to let somebody know. So K is simply just going to be called the potassium ion. The I is the nonmetal, right? That's my anion. The anions, when they're just one element like this, they get an ending of "-ide", kind of like we did for the Cl up here. So this was originally called iodine on the periodic table, so now I call it iodide. I know it sounds kind of funny, but that's what we call it. So now we just put those two names together. The K is potassium, the I is iodide, so it's potassium iodide. All right, this one I don't want you to get confused by the numbers. The numbers here have nothing to do with the name, okay? The only reason that there are numbers down here, if you remember, the crisscross method said that whatever the charge was here, I had to move that number down here. Whatever the charge was here, I had to move that number down here. The only reason there's other numbers here is just to balance out the charges that were there originally. But they have nothing to do with the name. So when you're naming this, ignore the 2 and the 3. So take a minute, pause the video, and I want you to use your periodic table and see if you can come up with the name. Okay, did you try it out yourself? Let's see how you did. So the Al is the metal aluminum, right? So that's aluminum. Is aluminum in a group on the periodic table that's always the same charge? Well, it's in group 13. 13 is always positive 3, right? So everybody already knows that aluminum is positive 3. Do we need a Roman numeral? Nope. So that's simply called the aluminum ion. By the way, how did I know it's positive 3? So remember what I just said. It's in group 13 on the periodic table, so I know it's positive 3. O on the periodic table is called oxygen. But since it's the anion, I have to change the ending. The ending would be called "ide." So this is not oxygen, it's oxide. So the name of this substance would be called aluminum oxide. All right, how are we doing? Is this making sense? This right here are like the easy ones. Right? You should definitely be able to do these with no problem after practicing it a few times. Now let's move up in complexity just a little bit. Let's make these just a little bit harder. Not a lot, just a little bit. Now, why is this a little bit harder? Well, look at that metal at the beginning. Okay, so this is FeCl3. Remember, the metal's always the first thing. Look at the metal at the beginning. We said that we have to determine whether the metal needs a Roman numeral or not. Well, Fe is iron. Iron is in the middle of the periodic table. It needs a Roman numeral. What Roman numeral do we put with it? Well, it's not immediately obvious. So what we need to do is we need to work backwards. So let's look at Cl first, and then we'll work back to the Fe for a minute. So let's look at Cl. If you look up Cl on the periodic table, Cl is chlorine, right? Except that it's the anion, because it's second. So what do we name it as? We name it chloride. But that's not the important part here. The important part is, what is the charge of Cl? Since Cl is in group 17, we have to remember, okay, if you haven't gotten this pattern down, you need to go back and review this. The pattern is that group 17 is always -1. So Cl is -1. But how many Cl's are in this formula? There's 3 of them. So if you have -1 for each Cl, but there's 3 of them, that's actually 3 negatives. So how many positives would Fe have to be to balance out 3 negatives? It must have been 3 positives. So now what's the Roman numeral that we have to put with Fe? 3. You see how we got that? So that 3 there tells us what the original charge was of the iron. And the iron needs the Roman numeral because there are different irons out there. It's one of those transition metals in the middle of the periodic table. Now, we already did the Cl part, right? We already figured out that Cl is called chloride. And so if we put these two names together, the two names, and we have to take the Roman numeral with it, it would be called iron 3 chloride. Right, let's try another one of those, right? You gotta work a little bit harder on these. So the first part of this is the Cu. Cu is the metal copper. Now, do you see where Cu, where copper is on the periodic table? It's in the middle of the periodic table again, right? It's in that transition metal area. The transition metals are metals that we don't know the charge of off the top of our heads. We don't have them memorized. They could be different charges. So we have to work backwards. So I don't know what copper's Roman numeral is going to need to be. I'm going to have to look at S first and then work backwards from there. So S, what element is that? Well, if we look that one up on the periodic table, that's what? Sulfur, right? S is sulfur. Sulfur is in group 16. Group 16 is always -2 charge. So this right here, this S would be called sulfate. sulfide, right? Sulfide, and it would have a -2 charge. Well, if you work backwards, then Cu must have been a +2 charge to balance out the -2 from the S. So this is going to be Roman numeral 2 after the copper, because I figured out that it must be +2 to go along with the sulfide that was -2. So there's a couple of things. Yes, you're going to have a listing of a bunch of names and formulas on a sheet, and you're going to have a periodic table that you can use also. But there isn't much out there that's going to tell you what the charges are unless you memorize the charges in that pattern that we learned from the periodic table. That's the one thing that you do need to memorize. All right, so we put those two together, and we know that CuS must be called copper 2 sulfide. All right, here's another one that I want you to try on your own. Okay, I want you to try this one. Pause this, look at the periodic table, try to figure it out, and then we'll go over the answer. All right, you try it out yourself. Al and P together. So Al is aluminum. Now, does aluminum need a Roman numeral? Well, I kind of tricked you here. I know the first two examples needed Roman numerals. Well, aluminum doesn't. It's in group 13. Group 13 is always +3. You don't need to tell anybody that. You don't need to write a Roman numeral for that. That's just aluminum. The P is from the element phosphorus, but remember, it's the anion, so anions always end in "ide." So that's phosphide. So this would be called aluminum phosphide. Hopefully this is starting to make sense. Again, the hardest thing about this is making sure that you have a periodic table and you have the list of ions that I'm providing to you so that you can look at those while you're doing this. Right? Unless you're going to memorize both of those sheets, and there's no reason for you to do that, you should be looking at them as you do these so that you can figure out what the names are. All right, let's try one more set of them. And again, we're going to go a little bit more complex. And you're probably looking at this one going, whoa, 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 wait a minute. There's a lot of things going on here. Yeah, but remember, this is an ionic compound. How do I know it's ionic? Because it starts with a metal, right? Ba is one of the metals on the periodic table. If it starts with a metal, that means it's made up of 2 ions. There are always 2 ions. It's always the metal. So it's always this part here, which is the metal. And that means that all the rest of this whole entire rest of this thing, must be the anion. Right? Has to be. It's not 3 things. There's only 2 ions here. So if the metal is 1 ion, then all the rest of this is the other ion. So Ba is barium. I know that because I can look it up on the periodic table. I also know that barium is always +2, so I don't need a Roman numeral because it's in group 2. They never need Roman numerals. That one's easy. What about the rest of that? What is that NO3 part called? This is where you're going to have to look on your ions list. And you're going to have to look up what NO3 is called. It's not going to be from the periodic table. You can't look up N and O and smush the names together. It has a special name on the ions list. And if you look up NO3, you'll notice that it's called nitrate. Now again, where is this 2 part coming from? Well, remember, the 2 part here is simply because barium was +2. So when we crisscrossed, there had to be a 2 that was brought down here. But that didn't affect the name. The name is the cation name and the anion name, barium nitrate. All right, let's try another one. LiOH. Remember, that's not 3 things. That's only 2 things. It's only 2 ions. The first part is the metal. Li is the metal. What metal is that? Well, you look on your periodic table. Li is lithium, right? Does lithium need a Roman numeral? It's in group 1, so no, it doesn't. It's always +1, so it's just lithium. That means that the O and the H must be together as a group. This is a polyatomic anion. And you can just look that one up right on the ions list, right? Again, you can't look up O and H on the periodic table and smush their names together. That's not the name of it. OH has its own special name, and you have to look on the ions list for that. It's called a hydroxide ion. So we have a lithium ion, a hydroxide ion, so together we call this lithium hydroxide. All right, you see how this is working? Okay, last one. This is as hard as they get. Doesn't get any harder than this. So I want you to try this one. If you can do this one without me telling you how to do it, then you know what you're doing. You're going to be fine. Go try it. Okay, did you try it? Let's see how you did. So Au is the element gold, right? That's my metal. Does gold need a Roman numeral? Yeah, it does, right? Because gold is there in the middle of the periodic table. It needs a Roman numeral. So I don't know what Roman numeral to put with it. I'm going to have to work backwards. So let's look up PO4. PO4 is a polyatomic because it has more than one element in it, right? It has P's and O's together. So PO4 you have to look up on your ions list. If you look up PO4, you find out that it's called phosphate. And what charge does it have? It has a -3 charge. So if the PO4, if the phosphate part was -3, then the gold, the Au, must have been +3 to balance it out, right? So we figured out what the Roman numeral is supposed to be by working backwards. We figured out the gold, it must be gold 3. We also said the PO4 was called phosphate. And so the name of this is gold 3 phosphate. Yes, by far the hardest one we did. But if you understand how we did that, then you're good. Okay? Then you've got this figured out. If you don't understand how to do this, if this is still confusing to you, you need to make sure that you're asking questions during class or writing me a message about the questions that you have so we can go over this further. Now, one other thing. You also need to be able to go backwards. I just gave you formulas and I had you come up with the names. What if I give you the name and I want you to write the formula? You should be able to do that. So let's just do 3 of those examples just so you understand how that works. To do these, when we work backwards, we're going to have to work with charges. We're going to have to do our crisscross method that we learned. So, magnesium fluoride. Remember, the first thing is always the positive, the second thing is always the negative. So magnesium is the positive. But how many positive? Well, the only way that I know is I'm going to have to look up the periodic table. Look up magnesium. Where is it? Magnesium is in group 2. If it's in group 2, then it's always a positive 2, right? So magnesium is Mg positive 2. Fluoride. Ide tells us it's the negative. So fluoride comes from fluorine. So you look up fluorine on the periodic table. Fluorine is F, right? What charge would it be? Well, it's in group 17. Group 17 is always -1. We just have to get through our heads. We have to remember this. Group 17 is always -1. So that means that it's an F with a negative charge, -1 charge. Now I have to put these two together. How do I put them together? Remember, I take the numbers that are here and a number that is here. Remember, this would be a 1, even though it doesn't show. There's a 1 there. I take those numbers and I crisscross. So how many mg's do I need? Well, this tells me I need 1. How many f's do I need? Well, this tells me I need 2, right? Crisscross the numbers. So MgF2 would be my formula. All right, let's do another one. Next one. First thing you got to do, what's the symbol for tin? So look up tin on the periodic table. Tin is Sn, right? Sn is the symbol for tin. What's the charge of the tin? Well, normally we wouldn't know, but it turns out they gave us a Roman numeral so that we know what tin's charge is. It must be positive 4, because that's the Roman numeral 4. So this is Sn with a positive 4 charge. Oxide, right? Oxide comes from oxygen, but it has what charge? Well, oxygen's in group 16. Group 16 we have to memorize is always -2. Group 16 is -2. Group 16 is -2. Okay, remember that. So this would be O with a -2 charge. So now we have to do our crisscross method. So crisscross would tell us that there's going to be 2 SNs and 4 O's. But wait a minute. You remember when we do crisscross, we have to reduce. Can you reduce 2 and 4? Yeah, you can reduce 2 and 4. This would be reduced to 2. This would be reduced to 1. So it's not SN2O4. It's just SNO2 because you have to reduce it. All right? All right, last one. Beryllium phosphite. So, first off, look up beryllium. You got to find it on the periodic table. If you're not looking for it, you're not trying. You got to figure it out for yourself. Where's beryllium? So you see beryllium, it is in group 2. So that means that it's a positive 2 charge, right? So that one we got figured out, Be positive 2. Phosphite. That's not phosphide, it's not phosphate, it's phosphite. So you have to look that one up. Anytime it ends with ate or ite, that means it's a polyatomic anion. You have to look it up on your ions list. So phosphite is on your ions list, and it's PO3 with a -3 charge. So, a little crisscrossing here. This 3 here tells me that I need 3 BEs, and this 2 right here tells me that I need 2 of this group. I need 2 PO3s. Now, I'm not going to distribute. I'm not doing math. I'm not going to distribute the 2 through. I'm just going to put that on the outside of the parentheses. So I needed 3 BEs, so BE3, and I needed 2 PO3s, so I put PO3 in parentheses since it's a group, and I put the 2 on the outside. All right? So you got to be able to do those. Again, if that was confusing, if any part of that was confusing, and it's all right if it is, but you have to ask some questions so that we can go over it further in class, that we're all clear on how to do this. Okay?